Good morning, students. Today we are going to do some questions based on Capgemini recruitment online test as conducted for this batch of year 2021. All right, if we talk about the Capgemini test, the paper consists of four sections. There is a portion for essay writing, then there is a section for gamified aptitude, followed by portions for quants and logical reasoning. Also, there are sections where they assess your programming and the subject knowledge of C, C++, Java, OOPS, DS, all those things. Okay. Our concern is not that section. Our concern is going to be the quant section in today's lecture. If we talk about the overall difficulty level of that particular paper, it is easy to moderate. The questions were not very difficult, they were on a easy scale, but obviously required a little thinking and logics in every question that was involved. So let's look at those questions. The first question that had come up in the paper. Okay, so A, B, C, D, and E are five consecutive integers. Consecutive means continuous and in increasing order of the size. Which of the following expression is not odd? So we need the expression that is even here. We're going to need the even expression. Okay. So A, B, C, D, E are given as consecutive. These are continuous. So either A, C, and E are odd. Either the thing is either these three are odd and B and D are even, or either A, B, C, D, E. If we talk about A, C, and E, either these are even and the other two, these are odd. These are the only two cases that is possible. If these are consecutive numbers, either it can begin with an odd number or it can begin with an even number. These are the only two cases that are possible. So we're going to go with respect to the options because that is easier rather than doing the generalization. Let's see what the options are given to us. Okay, option A is A plus B plus C. So option A has either two and one even number or two even. It has either two odd and one even, the first case, or two even and one odd according to the second case. So therefore this addition, it can either be even or odd. This is not this cannot give me the clarity. It is not going to give me any clarity. So this can either be even or this can either be odd. So I don't have any clarity. Similarly, option B and C also. Similarly, if we talk about option B and C also, so this is A and B, A into B plus C, A into B plus D. Similarly follows for these two also. I'm not clear whether this is even or odd because if I do A into B, A into B is odd into even. This is even plus C. C is an odd number, so I'll be getting a odd answer. Now, if these two A and A, B, and if it is A, B, C, D, E of the second case, here I'll be getting even. So it's either even or odd that is obtained from B and C. But if I talk about the case D, if let's look for the answer given in option D, A into C plus E. Okay, so condition for getting an even is if either both of them are odd, that is, it is odd plus or it is even plus even. If I look at A into C plus E, A into C, A into C is odd, odd plus odd, and E is also odd. So odd plus odd, this would give me even in the first case also. Now second case, if A, C and E, if these are even, A into C is even plus even, giving me even only. So any case, whichever it can be the first case also where A, C and E are odd and B, D are even, or A, C and E are even and B and D are odd. Both the cases, I'm going to get the same answer that for sure AC plus E is going to be even, it is not going to be odd. My answer becomes option D. Okay, next question. What is the sum of all four-digit numbers that can be formed using the digits 1, 2, 3, 4 when my repetition is not allowed? Okay, so when repetition is not allowed and I have to find sum of all possible numbers with no repetition, I have a formula for that and we're going to do it with that only. Because our prime concern in any exam is to save time in minimum time as quickly as I can do the question and with a 100% accuracy. That is what is going to be our objective. So we are going to go with respect to formula. So finding the sum of all the possible numbers that are formed using some digits, let's say there are n digits that are given to us, becomes first thing that we are going to use is n minus 1 factorial. N is my number of digits that is given to me. Next, I'm going to multiply it with sum of digits that I have. Whatever digits I have been given, the sum of all those digits into 1111 going on to n number n, or whatever the digits is going up to that. If we do multiplication, let's take for example here n is equals to 4, that is number of digits given to me is 4. N minus 1 factorial, 4 minus 1 factorial, into sum of the digits, sum of which digits? Digits that are given to me from where I have to form the combination. 1 plus 2 plus 3 plus 4. It is 10. Into, here I'll be using 1, 1, 1, 1 only. So this is actually one, it's something like 1111 or 11,111 or 1,11,111. That is what it means by 1111 going up to n spaces. Okay, so since n is 4, n means number of digits given to me. When I will solve this, this becomes 6 into 10 into 1111. Simply, my answer is going to be 66660. That is sum of all the digits that are going to be formed out of four numbers that is given to me. 1, 2, 3, 4. It is 66660. My answer is option D. Next, a play school has chocolates which can supply 50 students for 30 days. For first 10 days, only 20 students were present. How many more students can be accommodated into the earlier group such that the entire chocolates gets consumed within 30 days? Assume each student takes the same number of chocolates. Okay. Now, we'll be using Manday's concept. I know Manday's concept, MDH by W is equals to K, that is constant, and it can be extended for n number of groups, that is m1 d1 h1 by w1 equals to m2 d2 h2 by w2, and it will go on up to mn dn hn upon wn. And one more thing that I can do is, if I have a whole quantity, I can write it as a sum of two or three different groups. That is also that it can be done. It can be written in format of groups as well. So we are going to do it this way. Okay, so 50 students, number of men is 50 and number of days is 30. This is what my initial quantity is, 50 into 30. It is going to be equal to, for first 10 days only 22 students were present. That is first 10 M2 D2 plus how many students can be accommodated into the earlier group so that the chocolates get consumed in 30 days. Okay, let's say number of students who can get accommodated is X plus X into 10 days is already done, remaining days becomes 20. Okay, so when we will solve this, 1500 is equals to 200 plus 20x. Solving this out, 2x is equals to 130. My value of x, that is my total number of students, comes out to be 65. I need how many extra students can get into the group. So if 65 is the total number of students that is going to be there, 20 students were already present. So extra students becomes 65 minus 20, that is 45. My answer is going to be C, 45 students. Okay, next question. In how many ways can seven different objects be divided among three persons so that either one or two of them do not get anything? Okay, now this is a different type of situation where it's one or two of them do not get anything. Let's look at the cases. So we're going to form obviously cases so that we can see the clarity of number of ways in each of the case. So case number one is two guys don't get anything and all the items they go to only one person. So two of them are not getting anything and one is getting everything. So here now I have to select that who out of these three, who is the one that is going to get everything. So number of ways of selecting one person out of three becomes 3C1. That is three ways. I have decided that two are not going to get anything and one will be getting everything. But who is this one going to be? That is going to be 3C1. In three ways, I can select that one person. Okay, now case number two is one person does not get anything because it is given in the question either one or two of them do not get anything. So this is the first case where two of them is not getting anything. The case where not one is not getting anything, we are going to define that. So one guy doesn't get anything. So division of seven items is now going to be done among the two people. So one is not getting anything. Two is going to have the division of the objects between them. How we're going to do the division? Let's call them as A and B. The two people who are going to get everything, let's call them as A and B. So now A gets six objects, whereas B is now going to get only one object, because total there are seven different objects. A gets six, B gets one. So this becomes 7 factorial because 7 objects need to be divided, but out of them 6 is going to one person. So this becomes 7 factorial divided by 6 factorial. Answer comes out to be 7 ways. Now A gets 5 objects and B gets 2 of them. This becomes again 7 factorial divided by 5 factorial, 2 factorial, because whatever the repetition is, we have to always divide by that. On calculating, it comes out to be 21 ways. Now, A is getting 4, B is getting 3. Comes out to be 7 factorial divided by 4 factorial, 3 factorial. When we calculate this, comes out to be 35 ways. After this, all the cases are going to be reversed. A gets 3, B gets 4, 7 factorial divided by 3 factorial, 4 factorial, that is 35 ways. Next, A is getting 2 objects, B is getting 5 objects. This is going to be 7 factorial divided by 5 factorial, 2 factorial. Comes out to be 21 ways. Now A is getting only one object, is B is going to get 6 objects. Becomes 7 factorial divided by 6 factorial. Answer is 7 ways. Okay. So all these ways are defined. So total number of ways for case 2. Total number of ways for case 2 becomes 126. When we add all of this, 7 plus 21 plus 35 plus 35 plus 21 plus 7, this becomes 126 ways. This is going to be total number of ways. But right now, this is just the division of objects between A and B. I have to select these two people also. Out of the three people who are going to be the two among which everything is going to be divided, that will be selected in 3C2 ways. That is, out of three, how two objects can be selected becomes two ways. So actually, case number 2, my answer is not 126, it is 126 into 2. Okay, so when we do 3C2, this comes out to be 3. When we do this, comes out to be 378 ways. Total answer for my case 2 becomes 378 ways. Now, total number of ways overall, what my answer is going to be? It is going to be addition of case 1 and case 2, comes out to be 378 plus 3, that is 381 ways. My answer is option C, 381 ways. Next question. A, B, and C chosen randomly and with replacement from the set 1, 2, 3, 4, 5. The probability that A into B plus C is even is. For a matter of fact, we always need to remember is that A into B plus C, more or less it comes out to be even. But what is the probability that out of a given set it comes out to be even? That is what we have to find out. Okay, so case set that is given to me is 1, 2, 3, 4, 5. Okay, A into B. Let's A into B plus C is going to be even when both of them are either even plus even, or it is going to be odd plus odd. So in both the cases, in these two cases, it is going out to be giving me the answer that A into B plus C is going to be even. Okay, so probability of A into B being odd, A into B is equals to odd. So A being odd is 1, 2, and 3, 3 out of 5. And B being odd, because A into B will be odd only when both of them are odd. This becomes 3 by 5 into 3 by 5. Answer is 9 by 25. Okay, now A into B comes out to be even. A into B coming out to be even becomes A is also even, B is also even. That is 2 by 5 into 2 by 5 becomes 4 by 25. Okay, now this is 4 by 25. Next thing, what we can do is, if, or one more way that we can do this is, But if I do it this way, that a into b is even, and I do it by 2 by 5 into 2 by 5, I get the answer as 4 by 25, which is going to be wrong, because for a number there are only two options: either it is odd or it is even. If we do this, AB comes out to be, in one case it is odd 9 by 25, in another case it is even 4 by 25. If I add it, it comes out to be 13 by 25 only, which is almost just 50%. What about the rest 50% of cases? The rest 50% of cases comes out to be some uncertainty. So AB being even, we are not going to do it as 4 by 25, we are going to do it as 1 minus 9 by 25, because AB can either be odd or it can be even. There is no other way, or there is no other option for AB to be. So this comes out to be 16 by 25. So odd we have found out, even we have found out. Now AB plus C is even if A and B are both odd. So probability AB plus C for this whole thing to be odd comes out to be 9 by 25 into C, if it has to be odd, becomes 3 by 5. When we do the multiplication, comes out to be 27 upon 125. Okay. Or like we have already defined, if both of them is going to be even. So A into B plus C, if we consider it for even, so this becomes 16 by 25 into C being even becomes 2 by 5, 32 by 125. So either this case 1 is going to give me a even number, or my case 2 is going to be giving me a even number. So when it is or, I do addition of the cases. My answer is 27 by 125 plus 32 by 125, that is 59 by 125. Answer comes out to be 59 by 125, option C. Next question. There are 1000 ice cream vending machines in school. The first student goes to all ice cream vending. Second student visits every alternate machine. Third visits every third machine, and same the pattern will be following. Then to which vending machine will the most students visit? Okay. If we try to solve this question, solve using some AP or GP, it is going to be very difficult. So this question is actually based on application of number of factors. Number of factors is what we are going to use this, what we are going to use for solving this question. Okay. In the given scenario, it is clear that we have to find the number which has maximum factors in range of 1 to 1000. That is going to be our answer. Okay, so we are going to check it out with respect to options. So let's go for each option. Let's do the prime factorization of each option and find out which has the maximum factors. So if we talk about 560, 560 is 2 power 4 into 5 power 1 into 7 power 1. Total number of factors becomes 4 plus 1 into 1 plus 1 into 1 plus 1. That is 5 into 2 into 2, comes out to be just 20 factors. So number of factors of 560 is 20 only. 840, if we do, 840 is 2 cube into 3 power 1 into 5 power 1 into 7 power 1. Finding out number of factors becomes 3 plus 1 into 1 plus 1 into 1 plus 1 into 1 plus 1. That is 3 into 2 into 2 into 2. Sorry, not 3. 4 into 2 into 2 into 2 becomes 32 factors. Okay. Next thing. 680, if we talk about, 680 is going to be 2 cube into 5 into 17. Number of factors becomes 3 plus 1 into 1 plus 1 into 1 plus 1. That is 2 into 2 is 4. 4 into 4 is 16. Just 16 factors. Next, if we talk about 640, 640 is actually 2 power 7 into 5, which is 8 into 2. That is again 16 factors only. So if we talk about the number that has maximum factors between 1 and 100, I cannot go on finding it for every number. So what I can do is I can go with respect to options, check out of the given options which number has maximum factor. So here 840 has maximum number of factors. Therefore, the 840th vending machine will be visited by most of the students because it has maximum number of factors. Answer is going to be option B, 840. Next question. Rohan is proud of his Swiss watch that he got as birthday gift from his father. Roshni likes teasing her brother, and so on. One occasion she said, "What is there with a costly watch? The reflex angle between the hands are the same in yours and mine. If the time is 11:20, then what is the reflex angle?" So it's 11:20 that is given to us. AM, PM does not matter to us because even if it is AM or if it is PM, the angle remains the same. Irrespective of AM or PM, the angle is same. Therefore, you will not say that this question is wrong or the angle cannot be determined because AM is not given or PM is not given. That becomes irrelevant because the angle is going to be same for both AM and PM. So we have to find the reflex angle. How we're going to do is we're going to calculate per hour how much it is moving. So let's go for first the hour hand. So in 1 hour, how much it is traveling? 360 degree by 12, because for an hour hand it covers 360 degree in 12 hours. So in 1 hour it is going to cover 360 degree by 12, that is 30 degrees. Okay, now the gap between the two hands, the gap between the two hands can be given by, because it is 11 and 20. Okay, so if I'm talking about 11, 20 here and here, so it is 11 and 20 would be somewhere when it is 4, it is at 4, and it would have obviously moved a little more angle further from 4, it is not going to be exactly at 4. So there is a difference of 5 divisions. So angle of the hour hand is going to be 30 into 5, that is 150 degree. Now obviously it is not going to be at exactly 4, there will be a deviation in the hour hand at 11, because it is already far, this hour hand has already traveled something more than 11, because of which the minute hand would have also traveled something more than 4. To measure the deviation, we're going to calculate with respect to So what we have done here is we have found for 1 hour it moves 30 degrees. So for five differences or five divisions, it would have moved 150 degrees. But 1 hour is also equals to 60 minutes. So for 60 minutes, the hour end is moving 30 degrees. So for 1 minute, it would have moved 1 by 2 degrees. This can also be measured out. So for 20 minutes, it would have moved half into 20, that is 10 more degrees it would have moved. Okay, so angle at 11:20 now finally becomes 150 degree, because 150 is what would have moved by it totally, minus this 10 degrees, because this is going to be the deviation, becomes 140 degree. And I need to have the reflex angle, so the reflex angle becomes 360 degree minus the angle between the hands of the clock. So this becomes 220 degree. My answer is option A, 220 degrees. Next question. How many 7-digit phone numbers can be found with 6 and 5 at the right and extreme ends, respectively? Okay, now 7 digit, 1, 2, 3, 4, 5, 6, and 7 needs to be formed. 6 is fixed, 5 is fixed. Okay. One thing with phone numbers is here my repetition is allowed. Repetition is always allowed when I talk about a phone number, because phone numbers like 9977334441 are also there, or numbers like 9 and 5 zeros and something of that sort are also there, or numbers like 92345, 92345, all these numbers are possible. So therefore whenever we talk about a phone number, repetitions is always allowed. So 6 is fixed, 5 is fixed, but rest of the places, this is one way of filling this particular place, that is using just 6 here. 5 is also one way, but rest middle can always be filled in 10 ways. All the 10 digits that we have from 0 to 9, all these 10 digits can be used in between of these spaces. So now total number of ways becomes 10 raised to power 5, which is none of the options. So my answer is C, none of these. Next question. There are 10 points on a straight line AB and 8 points on another straight line AC. None of them being point A. Okay, so A is not on any of those points. How many triangles can be formed with these points as vertices? Okay, the triangle, if it is AB here, it has 8 points, and now this is AC, it also has AB. Okay, AB has 10 points, AC has 8 points on it. Okay, now how many triangles can be formed with these points as vertices? That is what the question is. So a triangle is going to be formed when it has at least one point out of the line where it is situated. That is, if we call in terms of collinear and non-collinear, if it has at least one non-collinear point. If all the three collinear points are taken, or in this case, if all the 3 points from the line A B is taken, or all the 3 points are on the line A C, triangle cannot be formed. Triangle will only be formed if I take 1 point from AB and 2 points from AC, or I take 2 points from AB and 1 point from AC, or I'm going to take just the reverse of it. Okay, so a triangle is going to be formed only in these cases. Otherwise, if all the three are from the same line, a triangle cannot be formed. So, number of triangles first becomes, first case that we considered, 2 points from AB and one from AC. In this case, it becomes 10C2 into 8C1. Now, next case that we considered, 1 point from AB and 2 points from AC, it becomes 10C1 into 8C2. This is what is going to be number of triangles that are going to be possible. Total number of cases becomes 10C2 into 8C1 plus 10C1 into 8C2. When we do this, when we do both of this multiplication and add it, this becomes 360 plus 280. Total answer comes out to be 640. Answer is option D, 640. Next, father is 5 times faster than son. Father completes a work 40 days before the son. If both of them work together, when will the work get completed? A very simple question from time and work is given, but with respect to efficiencies, we have to solve. Okay, so let the efficiency of father be F and that of son be S. So two efficiencies we have considered. According to the question, it is given father is 5 times faster than son. This is going to be the first equation. Let the total work that these people are doing, let it be X. I'm going for taking total number of work be X because then we can do the question in respect of efficiencies as well. Okay, now it is given to me. I know efficiency of a person is a person's 1 day work. That is how much that person has done in 1 day, that has to be given out. Okay, so X upon F, that is how much work father has done in 1 day. It is equals to X upon S, that is how much work son has done in 1 day, minus 40, because it is given father completes a work 40 days before the son does. So if father, whatever work father has done in 1 day is equals to whatever done work son has done in 1 day minus 40, is obviously completing it faster than that. So when we solve this, instead of F, I'm going to put out 5S. So X upon 5S is equals to X upon 5 minus 40. Now, from here, I'm going to get the value of S in terms of, I'm going to get a value of S in terms of X. Okay. So when you will solve this, S comes out to be X upon 50. Okay. Now you have the value of S, it comes out to be X upon 50. Just in terms of one variable, another variable, we can do this. We don't need the exact value. Just in terms of variables, we're going to do this. Now, F will be 5x by 50 because father is 5 times faster than son. Now, time taken when they work together comes out to be x upon x by 50 plus x by 10. Value of x would get cancelled out. When we do the calculation, it comes out to be 50 by 6 days, that is 8 1 by 3. day. My answer is option B, 8 1 by 3 day.